Question 1 says solve 4x plus 3 less than or equal to minus 17. This is an inequality problem and let's solve it. It's simple. 4x plus 3 less than or equal to minus 17. If we collect like terms, 4x will be less than or equal to minus 17. The 3 will cross and turn to minus 3. So 4x is less than or equal to what? Minus 20. Dividing both sides by 4, x is less than or equal to minus 20 over 4. And that will give me minus 5. So x is less than or equal to minus 5. And the correct option is option C. Question 2 says solve minus 5 less than or equal to 2x minus 1 over 3 less than 7. Alright, it's very easy to do. See how we're going to do it. A very simple way to do it is to first of all clear this fraction. And to clear this fraction is to multiply through by 3. Okay, so this is it. If I times minus 5 by 3, I will obtain minus 15. So the 3 is out of here already. I'm having 2x minus 1. If I times this 3 by 7, I will get 21. Simple. So I want to make x stand alone at the middle. So I'm having 2x minus 1 here. First of all, this minus 1 will leave. It means that I will have to add 1 to it. If I say minus 1 plus 1, I will be 0. So I will add 1 to both sides of this inequality. So this is minus 15 plus 1 less than or equal to 2x less than 21 plus 1. Okay, so what would that give me? This will give me minus 14 less than 2x less than 22. So we now divide both sides by 2, right? If I divide both sides by 2, divide this one by 2, I will get minus 7. Divide this by 2 to get 1, that's 1x. Divide this by 2 to get what? 11. And we can see this in option B, alright? So option B is the correct solution to this inequality. Now let's solve question 3. It says solve the modulus of 4x minus 5 less than or equal to 7. Okay, this is an inequality involving a modulus. Alright, it's simple. The absolute value of 4x minus 5 less than or equal to 7 is equal to, this is it, minus 7 less than or equal to 4x minus 5 less than or equal to 7. So if I add 5 to both sides, this is minus 7 plus 5 less than or equal to, if I add 5 to this one will cancel out. Remaining 4x less than or equal to 7 plus 5. Minus 7 plus 5 is minus 2. And this will give me 12. So dividing both sides by 4, we have minus 2 over 4 less than or equal to x less than or equal to 12 all over 4. Minus 2 over 4 is minus 1/2. And this will give me 3. So this is the solution set that satisfies the inequality. And this option is option A, right? So option A is the correct option. This is question 4. We have to solve this quadratic inequality. X squared plus 3x greater than 28. Okay? Now we have x squared plus 3x greater than 28. So if I say x squared plus 3x minus 28, I'll be having greater than 0. Now let's factorize the left hand side. Two numbers that when multiplied to give me 28 minus 28 and when added to give me plus 3. 4 times 7 is 28. So the numbers are plus 7 and minus 4. Because 7 times minus 4 is minus 28. 7 plus minus 4 is plus 3. So I'm having x squared plus 7x minus 4x minus 28 greater than 0. X squared Okay, if I factor x out from these first two, I'll be having x plus 7. Minus 4 is common to this. I'm having x plus 7 also. That means x plus 7, then x minus 4 is greater than 0. So I want to say, let x plus 7 into x minus 4 be equal to 0. So I can determine the critical point. From here, it means that x plus 7 equal to 0 or x minus 4 equal to 0. This implies that x is minus 7 or positive 4. So I will create a number line. All right. I'm having minus 7 at the left and 4 at the right. All right, we have 3 regions here. This is one region, this is another one, and this is another one. So I want to verify or determine which of these regions will satisfy the inequality. Okay. Now, in between this region, we have from negative infinity to minus 7. Here we have from minus 7 to 4. And here we have from 4 to positive infinity. So in between negative infinity and minus 7, we have minus 8. In between minus 7 and 4, we have different numbers, including 0. Yes. Then from 4 to infinity, we have numbers bigger than 4, such as 5. Let me use these numbers to verify which of these regions satisfy the inequality. This inequality here. You know, this is what I reduced to this. So everything here, they are the same. Okay. Minus 8. The inequality says greater than 0. So if I plug minus 8 here for x, will it produce a number greater than 0? Let's check. What's minus 8 plus 7? Minus 8 plus 7 is minus 1. So we have minus 1. Then if I plug in minus 8 here, minus 8 minus 4 is minus 12. Minus 1 times minus 12 is 12. And 12 is bigger than 0. It means that this region will satisfy the inequality. Oh, I'm supposed to draw a circle that is not shaded. This circle is not shaded, please. The circle is not shaded. All right, it's supposed to look like this. Then let's check out for this region. Of course, this region is not going to satisfy it. It's already known. If I plug in 0 here, 0 plus 7 is 7. If I plug in 0 here, 0 minus 4 is minus 4. 7 times minus 4 is minus 28. And minus 28 is negative. It cannot be bigger than 0. So this region will fail. If I plug in 5 here, this will be 12. Plug in 5 here, this will be 1. 12 times 1 is 12. It is positive. And it is greater than 0. Of course, this region will also satisfy the inequality. So the solution set is this. From all numbers less than minus 7 will satisfy the inequality. All numbers bigger than 4 will also satisfy the inequality. So we have x is less than minus 7 or x is greater than positive 4. Let's see which of these options will work for this. Option C is the correct option. All right, let's solve the fifth question now. We have to solve this inequality. Is a rational inequality. 3 over 2x greater than 1 over 3x minus 1 over 6. Okay, so what I normally do is to set one side of this inequality to 0. So we'll be having 3 over 2x minus 1 over 3x. If this one crosses, it turns to plus 1 over 6 plus, what am I writing? Then we have greater than 0. So the LCM of everything we have here is actually 6x. Yes, the LCM of 2x and 3x is 6x. The LCM of 6x and 6 is still 6x. 6x divided by 2x is 3 times 3, that's 9. 6x divided by 3x is 2x, is 2. Okay, 2 times 1 is 2. 6x divided by 6 is x times 1 is x greater than 0. 9 minus 2 is 7. So we have 7 plus x all over 6x greater than 0. So this is what I will do. I will set the numerator and denominator equal to 0 to determine the critical point. I will say let 7 plus x equal to 0. From here, x equals to minus 7, right? And I will say let 6x, which is at the bottom, be equal to 0. And from there, x is equal to 0. If you divide 0 by 6, we get 0. So I will use these 2 points to form a number line, that is minus 7 and 0. Three regions that we have. Let's verify which of these regions satisfy the inequality. In between minus infinity and minus 7, we have numbers less than minus 7, such as minus 8. In between minus 7 and 0, we have the numbers such as minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0. Let's use minus 1. And from 0 to infinity, we have numbers bigger than 0, such as 1. So I'm going to plug in each of these numbers into this inequality, the left-hand side, and see which of them will produce a number greater than 0. Greater than 0 means that the number must be positive. Only positive numbers are greater than 0. If I plug in minus 8 here, okay, it will be 7 minus 8 all over 6 times minus 8. Okay, 7 minus 8 is minus 1. 6 times minus 8 is minus 48, right? If minus cancel minus, we have 1 over 48, and this is greater than 0 because it is positive. So this region will satisfy it. If I plug in minus 1 here, it will be okay, 7 minus 1, which is 6. Then 6 times minus 1, which is minus 6. This will give me minus 1. And minus 1 is not greater than 0. It is less than 0. So this region will not satisfy the inequality. Of course, this one will satisfy it. Let's check it. Plug in 1 here. That's 7 plus 1. That's 8. Plug in 1 for x here. 6 times 1 is 6. So we have 8 over 6. It is positive and greater than 0. Hence, this one will satisfy it. So the regions that satisfy the inequality we have x is less than minus 7 or x is greater than 0. So which of the options here is correct? S less than minus 7, S greater than 0. That's option A. Option A is the correct option to the question. Question 6. Which of the following is correct? A. The absolute value of x less than 0. B. The absolute value of x plus y greater than or equal to the absolute value of x plus the absolute value of y. C. The absolute value of x plus y less than or equal to the absolute value of x plus absolute value of y. Option A is not correct because the absolute value of x is not less than 0. Absolute value make a number to be positive. So positive numbers are actually greater than 0. So A is wrong. There is what we call triangle inequality. And triangle inequality is that the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. And that makes option C to be correct. This is question 7. We have to express this in partial fractions. 25 minus 11x all over x plus 1 into x minus 2 into x minus 3. Okay, let's do this. We have 25 minus 11x all divided by the denominators are linear factors. So we're having three partial fractions, x plus 1, x minus 2, x minus 3. Of course, we are adding them. Since they are linear factors, we assign constants to their numerator. And the LCM of what is here is still this. That is x plus 1, x minus 2 into x minus 3. And here we have x plus 1, x minus 2, x minus 3, 25 minus 11x. So, if I divide everything here by this, I'll be having x minus 2, x minus 3 times a. That's a into x minus 2 into x minus 3. Divide everything here again by this, we'll be having x plus 1, x minus 3 times b. Of course, for c, we'll be having x minus 2. So, if they cancel out, we have 25 minus 11x equal to a. I'm not going to expand that. I want to eliminate two of the constants at the same time. So, let's say I want to eliminate a and b. They have x minus 3 in common. Of course, it's not here. So if I say let x, when x equal to 3, if I plug in 3 here, it becomes 0. Everything here becomes 0. Plug in 3 here, everything here becomes 0. But this one will remain. So this is 25 minus 3 times 11 is 33. This is 0, this is 0. Okay, let's see what this will be. 3 plus 1 is 4. 3 minus 2 is 1. Of course, 4 times 1 is 4. Times c, that's 4c. This minus this is minus 8. And this implies that c is equal to minus 2. We have gotten c. Now let's eliminate maybe b and c or a and c to get b. Let's get b. We have x minus 2 here and x minus 2 here. So if I say when x equal to 2, we'll be having 25 minus 22. Of course, 2 times 11 is 22. Put 2 here, 0. 2 here, 0. Everything here, 0, 0. So this will be 2 plus 1 is 3. 2 minus 3 is minus 1. So 3 times minus 1 is minus 3. 25 minus 22 is 3. That means b is equal to minus 1. Let's get a. So to get a, we have to eliminate b and c. Now, to eliminate b and c, what's common to them? We have s plus 1, s plus 1. So if I say let x be equal to minus 1, put minus 1 here. Minus 1 plus 1 is 0. Everything becomes 0. Minus 1 plus 1 is 0. Everything becomes 0. So we're having 25 plus 11, because minus 1 times minus 11 is plus 11. Minus 1 minus 2 is minus 3. Minus 1 minus 3 is minus 4. So minus 3 times minus 4 is plus 12. Of course, 0, 0. 25 plus 11 is 36, right? 36 equal to 12a. That implies that if we divide both sides by 12, a is equal to 3. So the partial fraction now, we have, what is a? A is 3, so this is 3 all over x plus 1. What is b? B is minus 1, so we have minus 1 over x minus 2. And what is c? C is minus 2, so we have minus 2 all over x minus 3. It means that 25 minus 11x all over x plus 1, x minus 2, x minus 3 is equal to this. This is the partial fractions of this compound fraction. The next question says, express x squared all over x cubed minus 1 in partial fractions. We have to express x squared divided by x cubed minus 1 in partial fractions. Look at the fraction very well. The numerator, the degree of the numerator is 2, and the degree of the denominator is 3. Of course, the degree of the numerator is less than the degree of the denominator, so we just proceed. If they were to be of the same degree, we would have performed polynomial division, but that's not the case now. The denominator is a difference of 2 cubed. Okay, it is x cubed minus 1, and 1 is the same as 1 to the power of 3. So the formula for difference of 2 cubed, if we have a cubed minus b cubed, it means a minus b into a squared plus ab plus b squared. This is the formula for the difference of 2 cubes. That means that x cubed minus 1 is x minus 1 into x squared plus, it will now be x times 1, that's x, then plus 1. 1 squared is 1. That's it. So this will now be x squared all over x cubed minus 1 is equal to x squared divided by x minus 1 into x squared plus x plus 1. So we now split it into two fractions because we have two denominators, one with x minus 1 and the other with this. This x squared plus x plus 1 is an irreducible quadratic factor. That is we cannot factorize it. Okay, and because it is a quadratic factor, is irreducible, we assign a polynomial, we assign a linear factor to it, ax plus b. Probably I'll be using c. This should be b, bx plus c. I'm going to use a here. This factor x minus 1 is a linear factor, so let me start with a, the first constant, then let me use bx plus c there. That's it. So x squared divided by x minus 1 into x squared plus x plus 1 is equal to the same thing here. That's the LCM. If I divide this LCM by this, I'll get x squared plus x plus 1 times a. That's a into x squared plus x plus 1. Divide the LCM again by this, you have x minus 1 times this. So x squared, this will cancel this. Alright, so we have x squared is equal to ax squared plus ax plus a. I use a to multiply everything here. Plus, if I expand this, bx times x, that's bx squared. Bx times minus 1 minus bx. C times x, that's cx. C times minus 1 minus c. So we are going to say comparing coefficients. There is a term in x squared at the left. There are some terms in x squared at the right. The coefficient of x squared here is 1. So I'm going to say 1 is equal to, for x squared here, we have a as the coefficient here and b as the coefficient of x squared here. So I'll add their coefficient. That's equation 1. There are some terms in x here. We have 3 terms in x here. Ax minus bx cx. There is no term in x here, so that is 0. Then the terms in x here, we have a minus b plus c. That's equation 2. We have some constant as well. A is a constant, minus c is also a constant. There is no constant here. That makes it 0 also. So we say a minus c. That's equation 3. So this is how I'm going to solve these 3 equations simultaneously. From equation 1, okay, let's say from equation 3, let's use equation 3. A is equal to c. If minus c cross to the left, it turns to plus c. So a is equal to c. Alright. Since a is equal to c, then this equation 2 will now be 0 equal to a minus b plus a. Yes, because a is c. Oh, this is a. Because a is c. So a plus a is 2a. That will be 0 equal to 2a minus b. This is our new equation. So from equation 1 and 4, I can determine a. If I add both equations, 1 plus 0 is equal to 1. A plus 2a is equal to 3a. C plus b plus minus b, that's 0. This implies that a is equal to 1 over 3. And if a is equal to 1 over 3, to get b, if I put 1 over 3 here for a, I will say 1, I'm coming from here now, is equal to, a is now 1 over 3. 1 over 3 plus b. So I can get b by saying 1 minus 1 over 3. This one will cross, turn to minus, equal to b. 3 times 1 is 3. 3 minus 1 is 2. So b is equal to 2 over 3. A is 1 over 3, b is 2 over 3. What's c now? Since a is equal to c, it means that c is also 1 over 3. So c is also 1 over 3. So the partial fraction will now be x squared divided by x minus 1 into x squared plus x plus 1 is now, what's a? A is 1 over 3 all over x minus 1. Then plus this is bx plus c. What's b? B is 2 over 3. What's c? 1 over 3. So this is 2 over 3x plus c, 1 over 3, all over the denominator there, which is x squared plus x plus 1. So this is simply 1 all over this 3 here, we multiply what is under, plus I can simplify this numerator to obtain 2x plus 1 all over 3, right? Yes, because they have the same denominators, x squared plus x plus 1. So finally this will be 1 all over 3 into x minus 1 plus this 3 here will multiply this denominator, we have 2x plus 1 all over this 3 into s squared plus x plus 1. So this is s squared over s cubed minus 1 in partial fractions. What is the coefficient of x to the power of 4 in the expansion of 1 plus x all to the power of 5? This is a question under binomials, and let's solve it. We are going to make use of the general term for a binomial expansion. The general term for a binomial expansion, if we have x plus a to the power of n, it is n combination rho into x to the power of n minus rho into a to the power of rho. We are looking for the coefficient of x raised to the power of 4 here. Now, this binomial 1 plus x to the power of 5 can be written as x plus 1 to the power of 5 also. So, n here is 5, x is tx, a is 1, but rho is missing. So, this will be 5 combination rho. Of course, we don't know what rho is. Into x to the power of 5 minus rho. A is 1 to the power of rho. So let's first of all determine what rho is. Okay. Now, they said the coefficient of x raised to the power of 4. That means the power of x is 4. That's what it means. So if the power of x is 4, it means that this power of x here, which is 5 minus rho, must be equal to 4 before we can achieve x raised to the power of 4. So everything here is equal to 4, since we are looking for the coefficient of x raised to the power of 4. You get the point? And if 5 minus rho is equal to 4, it implies that 5 minus 4, which is equal to 1, is equal to rho. That means rho is equal to 1. So we can say 5 combination 1, rho is now 1, into x to the power of 5 minus 1, which is 4, times 1 to the power of rho, and rho is 4. What's 5 combination 1? That's 5 factorial divided by 5 minus 1, which is 4 factorial, times 1 factorial itself, times x to the power of 4. Of course, 1 to the power of 4 is still 1. 5 factorial divided by 4 factorial is 5. 1 factorial is 1, so we have 5x to the power of 4. That means the coefficient of x to the power of 4 here is 5. So 5 is the coefficient of x to the power of 4 in the binomial expansion of 1 plus x to the power of 5. The answer is option C. In this question 10, we have to find the term in x cubed in the expansion of 1 plus x to the power of 5. It is the same binomial that we used in question 9. That's what we're also dealing with here. The term in x raised to the power of 4 in the expansion of 1 plus x to the power of 5 is 5x raised to the power of 4. This is a term that contains x raised to the power of 4. So we are looking for the term that contains x raised to the power of 3 here. Using the same formula that we used just now, n combination rho into x to the n minus rho times a to the power of rho. In this case now, x is x, a is 1, 5 is n. What's rho? Rho is unknown. Well, we are looking for the term that contains s raised to the power of 3. It means that n minus rho must be equal to 3. So since n is 5, we now have 5 combination rho into x to the power of 5 minus rho. Then we have 1, which is a to the power of rho. And since it is x to the power of 3, therefore 5 minus rho must be equal to 3, which implies that rho is equal to 2. So when rho is equal to 2, the power of x is 3. You can say that 5 combination 2 into x to the power of 3 times 1 to the power of 2. And 5 combination 2 is 5 factorial divided by 5 minus 2 factorial into x cubed. 1 squared is still 1. So this is 5 factorial all over 3 factorial times 2 factorial into x cubed. If I divide 5 factorial by 3 factorial, I'll be left with 5 times 4. Yes. 2 factorial is 2. 2 here is 1, 2 here is 2. So what am I having now? I'm having 10. 10x cubed. So the term in x cubed is 10x cubed, and the coefficient of x cubed here is 10. Now, this is question 11. Find the term in x raised to the power 9 in the expansion of 2x squared minus 1 over x all to the power of 12. Okay, remember we said that this is the nth term for the binomial x plus a raised to the power n. So 2x squared here is standing for x, minus 1 over x is standing for a, 12 is standing for n. So we are going to say 12 combination arrow. Arrow is unknown. X now is 2x squared, all raised to the power of n minus arrow. N is 12. What's a? Minus 1 over x raised to the power of what now? Arrow. You get the point now. So let's merge the x together, or the x, let's merge them. This is 12 combination arrow. If I expand this bracket, at law of indices, these two will be raised to power 12 minus arrow. This x squared will also be raised to the power of 12 minus arrow. 2 times 12 is 24. 2 times minus arrow is minus 2 arrow. So x to the power of 24 minus 2 arrow. Then this is minus 1x raised to the power minus 1. Yeah, that's minus x inverse. So I'll say 12 combination arrow, 2 to the power of 12 minus arrow, x to the 24th minus 2 arrow. This arrow will affect the minus 1 and the x inverse. So it will be minus 1 raised to the power arrow times this x raised to the power minus 1 times arrow. That's x raised to the power minus arrow. So I will now group the arrows together, or the x together. 12 combination arrow, then into 2 to the power of 12 minus arrow, x raised to the power 24 minus arrow times x raised to the power minus arrow. They have the same base, so I will add their powers. Minus 2 arrow minus arrow is minus 3 arrow times minus 1 raised to the power arrow. So since x must be raised to the power of 9 based on the question, it means that 24 minus 3 arrow, which is the power of x here, is equal to 9. So from here we can now determine the value of arrow. So 24 minus 9 is equal to 3 arrow. If I divide everything by 3, this will be 8, this will be 3, and this will be arrow. 8 minus 3 is 5, so arrow is equal to 5. So we can now say from here, from this equation, 12 combination 5, arrow is now 5, into 2 to the power of 12 minus 5, that's 7, x to the power of, everything here will be 9. 3 times 5 is 15. 24 minus 15 is 9. Then we have minus 1 to the power of arrow. Arrow is 5. If you raise a negative number to an odd power, the negative number will remain. So the answer is going to be a negative result. So 12 combination 5 is 792. So we have 792 times 2 raised to the power 7. What's 2 raised to the power 7? 128 times x to the power of 9. 128 times 792. That's 101376 times the minus 1 outside. That will be minus 101376 times the x raised to the power 9. This is the term in x raised to the power of 9. Now, this question, still under binomial, says, what is the term independent of x in the expansion of 2x squared minus 1 over x all to the power of 12? Okay, the same binomial here is what we have here. Question 11 and 12, they are the same. So I'll just skip these steps until I get to this point. I'll stop here. This is very important. Now, the term that is independent of x is simply the term in which the power of x is equal to 0. You get that? The term independent of x is the term that has x raised to the power 0. You see this case now, we have x raised to the power 9. So, if it is x raised to the power 0, of course, x raised to the power 0 is 1. So, it's as if there is no x in the term. That's what we are saying. So, I'll just come here. Okay, all of these steps, I'll skip them because I'll still get to this point. So, from here, since the term is independent in x, that means the power of x must be 0. I will set everything here to 0. That's what it means. So 24 minus 3 arrow must be set equal to 0. So let me just write it. 12 combination arrow into 2 to the 12 minus arrow. I'm copying from that expression. X to the power of 24 minus 3 arrow into minus 1 to the arrow. Good. So we now set this one to 0. 24 minus 3 arrow must be equal to 0. And then, if you divide both sides by 3, this will be 8 minus arrow equal to 0. From which arrow is equal to 8. Right, so arrow is 8 here. It means that we now have 12 combination 8 into 2 to the power of 12 minus 8. What's 12 minus 8? That's 4. Everything here is 0. Yes, x to the power of 0. Then we have minus 1 to the power of 8. Okay, so this means that 12 combination 8 is 12 factorial divided by 12 minus 8, that's 4 factorial, times the 8 factorial itself, and that's 495. So 12 combination 8 is 495. So we have 495. 2 to the power of 4 is 16. Of course, minus 1 raised to the power 8 is positive 1. So 495 times 16 is 7,920. X raised to the power 0 is simply 1. So we have 7,920. This is the term that is independent of x in the binomial expansion of this. You get the point now? This question says, what is the coefficient of x cubed in the binomial expansion of x plus 1 all divided by 2x plus 1? Now, this is the same thing as saying x plus 1 into the inverse of 2x plus 1. They are the same. So we now have to expand 2x plus 1 to the power of minus 1. x plus 1 is not to be expanded. Okay, it's already in the simplest form. Let's expand this. The formula that we use to expand negative and fractional index is this. If we have 1 plus x to the power of n, where n is negative or fractional, it is simply 1 plus nx plus n into n minus 1 times x squared all over 2 factorial plus n into n minus 1, n minus 2 times s cubed all over what? 3 factorial plus n minus 1, n minus 2, n minus 3 to the x 3/4 all over 4 factorial, and so on and so forth. So in this case now, if I want to expand 2x plus 1, of course 2x plus 1 is the same thing as saying 1 plus 2x. It will now be 1 is 1, x is now 2x. So anywhere I see x here, I'll write 2x. Anywhere I see n, I'll write minus 1. So I'm having 1 plus minus 1 times what's x? What's x? X is 2x, remember? Plus what's n? N is minus 1. Minus 1, minus 1. S is 2x. 2x all squared all over 2 factorial. Of course, 2 factorial is 2 times 1, that's 2. Plus n is minus 1. Three factorial is 6, and so on and so forth. So this is simply 1 minus 1 times 2x is minus 2x. Minus 1 times minus 2 is plus 2. You get it? This is minus 2, this is minus 3. Minus 2 times minus 3 is plus 6. Times minus 1, that's minus 6. 2 cubed is 8. S cubed is s cubed. Okay, so we have 1 minus 2x, 2 cancel 2, plus 4x squared, 6 cancel 6, minus 8s cubed, and so on. So this is the expansion for 2x plus 1 inverse. So therefore, x plus 1 into 2x plus 1 inverse is now x plus 1 times everything here. We are trying to determine the coefficient of x raised to the power 3 in this expansion. Okay, let's expand it. S times 1 is x. X times minus 2s is minus 2s squared. X times this is plus 4x cubed. If I multiply x by any other number here, it will be increasing. So let me just put plus, plus, plus. You get the point now. Then I'll come here. 1 times 1 is 1. 1 times this is minus 2x. 1 times this is plus 4x squared. 1 times this is minus 8x cubed. Plus, plus, plus. The terms that have x cubed here, 4x cubed and minus 8x cubed. So 4x cubed minus 8x cubed is simply minus 4x cubed. That means the coefficient of x cubed here is minus 4. This is question 14 under set. The question says, find the power set of set A, which has the element A, B, C, D, and E. Okay, if I know what power set is, then I will know that the answer to this question is option E, which is none of the above. is simple. The power set of a set is the set of all possible subsets of that set, including the empty set. I just said the power set of a set is the set of all possible subsets, okay, of that particular set, including the empty set. So power set actually is a set and not a value. It is a set and not a what? A value. I deliberately wrote the options out so that you understand easily what I'm doing here. The power set of this set A, let's call it phi, is simply the set of all possible subsets. All possible subsets of this set, we have the set A, we have set B, we have C. Each of the elements there are a subset of this particular set. We have D, we have E, we have AB. You understand what I'm doing now? So we begin to arrange the numbers. We have A, C. Of course, I will not be able to write out everything, but I'm just trying to show you what a power set is. We have A, B, C, and so on and so forth, including the empty set. This is what power set is. But if I want to determine the number of possible subsets in this power set, I will now use the formula that says 2 raised to the power n. N is the cardinality of the set. By cardinality, I mean the number of elements in that set. 1, 2, 3, 4, 5. And let's give me 32. So don't be quick to choose option C because that's the wrong option. If they had said, what is the number of possible subsets of this set? Of course, 32 would have been the correct answer. But the question asked for power set. So power set is a set and not a value. I'll not be able to write options for all of the questions, but just follow me. If A, this is question 15, is the set of elements A, C, K, S, U, and B is the set of the elements Y, T, P, L, M, A. You can see that Y, T, P, L, M, A. Find the least possible universal set. Universal set as it is, universal set actually is the set of all elements for a given problem. The universal set contains all the elements of a given problem, and all other subsets that come from that universal set actually have their members from that universal set. Okay, so to determine the least possible universal set, we just simply take the union of A and B. We combine these elements and this one to form the universal set. Okay, let's combine the sets in order. We have A, C, K, S, U, Y, T, P, L, M, A, then C, then I think K before L, M, then we have P, then we have S, then we have U, right? Okay, we have T before U. This is the least possible universal set. In question 16, we are given a set Q 1, 2, 3, 5, 8, and 9, and set P 4, 5, 7, 10, 11, and 12. We have to find the least possible universal set for P and Q. Since the universal set is not a separate set, like we are not given the set for universal sets, okay, so we don't know all elements that may be in that universal set. But what we are saying now is that if I combine this set A, the element in set A and the element in set B together, I will form a set which is also a member of the universal set. So since we don't know what other elements are in that universal set, we just take the union of these two sets. Q is this and P is this. There are no other set given, no other information given. So the least possible universal set for P and Q is simply the union of these two sets. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. It's simple. Combine everything. 1, 2, 3, 4, 5. There's no 6, 7, 8, 9, 10, 11, and 12. This is the smallest possible universal set for P and Q. In question 17 that we can see now, we are given the universal set A, B, C, D, E, F, G, and H. Those are the elements in the universal set. And we are given the set Q, which is a subset of this set C, F, G. We have to find Q prime or Q complement. This is Q complement. The complement of a set is the set of all elements that are in the universal set but are not in that given set. Therefore, the complement of set Q is the set of all elements in this universal set but they are not here. So which elements are here that are not in this Q? Q has C, F, and G. So if I remove C, F, and G, I'll be having A, B, D, E, H, right? A, B, D, E, H, because C, F, and G are there. This is Q complement. This is question 18. Let the universal set be the set of element X such that 1 is less than or equal to X and less than or equal to 20. X is an integer. P is the set of elements X minus 1 such that 10 is less than or equal to X and X less than or equal to 18. X is an even number. Q is the set of element X such that 2 is less than X and X is less than or equal to 15. X is odd. And arrow is the set of element X such that 1 is less than X and X is less than 20. In this case now, X is a multiple of 3. We have to determine the intersection of Q and arrow. That is Q intersection arrow. Okay, let's do this very quickly. We are concerned about Q and arrow, so I have no business with P. Okay, now watch. This is the universal set 1 to 20, right? Okay, let's write it out. The universal set is simply 1, 2, 3, 4 up to 20. That's what this means. 1 is less than or equal to X and X less than or equal to 20. So the numbers are from 1 to 20. 1 and 20 inclusive. 1, 2, 3, 4, 5 to 20. What will be the element in set Q? 2 less than X less than or equal to 15. X is odd. Okay. In this case, X is an integer. So integers are both positive and negative numbers, including 0. So all numbers here are allowed in this set. So here now, the restriction is that X is an odd number. So first of all, the numbers are from 3 to 15. I said 3 to 15. 2 will not be part of the set because there is no equal to here. We only have equal to here. So the numbers I am going to choose these odd numbers from between 3 and 15. 15 is inclusive. So odd numbers between 3 and 15, yeah, 3 itself, 9. What am I saying? 3, we have 5, 7, 9, 11, 13, and 15. This 5. So these are the odd numbers between 2 and 15, 2 not inclusive. You get the point now. 3, 5, 7, 9, 11, 13, and 15. Okay, arrow is the set of numbers X such that 1 is less than X less than 20. And X is a multiple of 3. So what will be arrow? First of all, the 1 and 20, they are not inclusive. So the multiple of 3 we are going to choose are from 2 to 19. That's what I'm saying. 1 and 20 is not inclusive because there is no equal to for both inequalities. So I'm going to consider from 2 to 19. So multiples of 3 from 2 to 19 include 3, 6, 9, 12, 15, 18, full stop. 3 times 1, 3 times 2, times 3, times 4, times 5, times 6. 3 times 7 will be 21. 21 is not here. So what is Q intersection arrow? Q intersection arrow. Intersection is the set of all elements that is common to both sets. That are common to both sets. So which element is here that is also here? 3 is there. 9 is there. You can see it very well. 15 is also there.